So, good afternoon and welcome. A few little housekeeping things just before we start. We're not expecting a fire, so if there is, you'll notice the colleagues outside in the red shirts. If you follow those out the room as quickly as you can, that would be good. We've got a lot of AV stuff here, so if you can ensure that your phones are switched to silent, really appreciate that. If not, we all are going to have the same conversation with whoever calls you. Anything else worth mentioning before we start? Sorry? Oh, just the live stream, yes. Okay. So, yes, I've just been reminded, so a great shout out and welcome to the people who were basically streamed, and also to our Dublin office who are also watching this as well. So, with no further ado, I think I'll basically start kicking off. So, today's agenda, I'm going to be basically your host for the next hour until the break, and I'll then basically come back for the last session after my colleague Aram does the sort of the two middle presentations. So, what are we going to talk about? So, the good news is, if you're here to listen to Red Hat Enterprise Linux, then you're in the right place. If you haven't come to listen to RHEL, this is going to be a long, long afternoon. Anyway, what do I do? So, Adrian Ceward, I'm a solution architect within the UK. I do spend a lot of time on a particular set of accounts, but I'm actually here in my other role, which is actually to look after the platform, as we call it. So the stuff that a lot of people find boring, which is the operating system components, I actually find quite interesting. So I'm interested, and hopefully this will come through as we go through the rest of the slot. So the other thing worth saying is this is going to be reasonably technical. We're going to do the Q&A towards the end. So if you've got anything which, as I said, you need to go over, please sort of stop us towards that point. So with that, I shall move on. So there's a few little slides just to basically set out what we're going to talk about. The whole idea of really why we're talking today is effectively we brought out a newer version of Red Hat Enterprise Linux. So I'll try and avoid buzzwords, acronyms as far as we go, but the one that we can't move away from, yes, the word RHEL will be mentioned. I have no idea how many times I'm going to mention the word RHEL, but I'm going to basically see how many I can get away with. It's a system that's evolved over time. It's not something that's basically we just brought out last week. It goes back to our very first versions of Enterprise Linux, and it is a way to basically evolve and work with effectively what you as customers, you as partners, you as users, actually use the systems for. It enables you to basically do more. It enables you to basically look at what was traditional and basically look towards the future as well. We've tried, as far as the design of the system is concerned, to actually make it easy enough that whatever your workload is going to be it is supporting the legacy or older systems, but also towards the newer generation when you're building new applications. So it's your future. It's high performing. I'll talk about that a little later in terms of, yeah, we've got to be able to prove exactly how we go through. It's got to be able to scale. And a lot of the cases we'll talk about actually how those things will actually work. I've mentioned already it is for today and tomorrow. And of course, you may notice we've got the new logos on as well. So we're all compliant as we move on. Before I get into the rest of the feature set, it's worth basically going over what the prime reason, basically, or the biggest change in terms of Enterprise Linux as we've seen it. And that is the ability, which we'll cover in more detail later on, but we now have a base operating component and we have the application stream that allows you to look at things at a different speed. So if you take nothing else from the rest of the slides, that is one of the principal reasons what we've done around Enterprise Linux 8, or RHEL 8 for short. It's also worth mentioning from the subscription, we're not making you take this version. We're hoping you're going to use it, but subscriptions to Enterprise Linux are basically which version you wish to use. So we're coming to the end of RHEL 5, RHEL 6 is still in mainline support, RHEL 7, and now we have RHEL 8. So you have a choice of when to use the particular version numbers. It could be for whatever workload, it needs to be on a certain version number. We understand that. But your subscription allows you to choose and move when you see fit. You've got 10 years of support and then extra life on top of that. So you don't have to make decisions straight away. It basically works through your life cycle of your applications. But before I get into the rest of what is RHEL 8, it's probably worth mentioning RHEL 7. So hopefully you're aware that before 8 came 7, and as part of RHEL 7, there were a number of things that we basically worked on. So I basically stood up back in 2014 and went over effectively what RHEL 7 was trying to do. And if we compare RHEL 7 to RHEL 8, this is where basically we were RHEL 7, and we brought in containers for the first time, better Windows operability, etc. So that's where we were. That was the baseline of where we're moving to. But since RHEL 7 first came out, and before RHEL 8, there's a number of things that we did in between. So whenever we brought out the sort of the service releases, so 7.1, 7.2, 7.3, etc., we brought more functionality in. So if you've not necessarily been looking too closely in terms of what we've added, there are some very useful components that you basically may want to look, even if you're not going to go to RHEL 8 straight away. The first one of these is USB guard. Very simple requirement behind USB guard. This stops someone plugging in a USB stick into a server or a workstation, if you wish to deploy it that way, and basically able to pull data off that unless it's an approved stick. It just won't work. So it's actually a security feature that might actually be useful to deploy even if you've basically got other tools. So only approved sticks will work. You can't just plug in a keyboard or a mouse unless you want to allow so, but it allows you to basically work on those systems as a more secure environment. And that's built in. That's part of the kernel. There's no way around it. Another useful item from RHEL 7. So this basically came in basically in the 7.4, 7.5 timeframe, but also you're thinking about, you've had the ability to encrypt disks for quite a while now through basically the Lux component, but now you have the ability to have a network service to include the decryption of the disk. Why is that important? Well, very simply, if someone basically walks off with your server, if you still have servers in your still environment, it's not going to do them a lot of good, because unless it's plugged into the network, it won't decrypt the hard disk. Plugged into your network, I should say. So very simple, it's built in. The network service is built on, well, unfortunately, we do have engineers deciding what the names of these services should be. So we have Tang and we have Clevis. The good news is they don't stand for anything. But I say we just have to think sometimes, well, that's okay. It's just a way of basically describing what these particular components are. From an administrator's point of view, the good news is you're not just limited. If you wanted to decrypt, you could do, but effectively it reduces that whole environment, the ability for people to basically walk off with your kit, because it's useless to them, or at least the data is. So that's RHEL 7. So a little difficult to see on the screen here, but that's a black 8 on a black background. Now, I like that because you don't know whatever else I was going to actually say on this slide, but effectively, we do like the new 8 logo. So anyway, so black, I like the black one. My backdrop is this one because you can actually see your icons on terms of black screen. Anyway, so I mentioned this very quickly. The other thing I should say is I've got quite a few slides to get through before the break. So at some point I'll decide I'm not going fast enough, and I will speed up. I won't warn you, I'll just go faster. So while I still have some time in hand, I mentioned subscriptions. I've already talked about the fact that you choose when you want to. Those technology components you basically use when you want to basically use them. We're not going to force you to take them early. So if we look at what the RHEL family from 7 towards 8, what are we talking about? So the things that remain the same. So you go back to the office and someone will say, well, what is RHEL 8 compared to what I'm using today? Today, effectively, you're getting exactly the same thing, which you see on the left-hand side of the screen. You've got an enterprise operating system that works across all footprints. I'll talk about that later. The development process still stays the same. So we have Fedora at the top, and then once we take a cut of that, we basically optimize it, we make it bulletproof, we make it mission critical, and then effectively we call that RHEL. You've got 10 years of support, and we're basically a partner ecosystem that takes us forward. You also have satellite, the ability to manage that service basically moving away from ability from one person to manage a few systems to one person be able to manage thousands of systems. So satellite basically provides that set of tools. But what we're doing now is we're basically changing the delivery schedule and structure to a large extent. We're giving you a predictable release schedule. I'll talk about that in a second. More life cycle options, we'll go through that, and of course more frequent application updates. So there's going to be good reasons if you look at your environment and think, well, I'm going to stay on the same version of the operating system for the next 10 years, and I don't care what comes out, you're going to be okay. So you can go quite happy. If you want to use the latest and greatest versions of PHP or Perl or whatever it is, you're going to be okay because they can change as well. And that's the application stream we'll talk about later. So another quick eye chart for you. And this is the one that if you go back to the office and say, this is what it's all about, you can now sleep the rest of the afternoon because this effectively is the big numbers. And the big numbers is kernel 4.18. Anyone really worried about kernel 4.18? From our cadence, it doesn't actually matter what version number I put there, because as soon as we basically take a snapshot of the kernel, we're backporting features and functions from the kernel itself. So it just happens to be, when you look at the system, that's the version it's going to be for the next 10 years. Okay? Or as long as I'm using it. Not caring about compilers. Important if you're actually looking at multi-architecture, so not just x86. You'll notice that we now have ARM 64-bit. So that's now fully supported if you weren't using it before. IBM Z's still there. The little endian version of Power is supported. And that effectively is what we see customers requesting. So that effectively is what we see the market for people who are deploying on their own systems and also in terms of cloud. Don't have to mention anything about the default file system. XFS has remained since version 7. I'm going to talk about Yum in a second. Time synchronization, not worried about that one. And if you're really into systemd, we've updated the version number. And looking around the room, it doesn't look like anyone's really interested that we've changed the version number of systemd. Anyway, it's faster, less bugs. You'll love it. Now, this is the first time I've been allowed to use this slide, so this is good news. And that is dynamic kernel patching. What is that? That's live patching of the system today. No, if you don't have the ability to basically reboot a server, you can now have live kernel patching. Now, this good news is it will also be available for RHEL 7.6 and the next version, which might be called 7.7, but you'll get that during the basic life cycle 8. It gives you the ability for services that can't be closed down, but you need to patch to run them today. And we'll basically keep providing those patches as a part of the system. Just another feature of effectively what the enterprise subscription provides you. So I said, that's the first time someone's allowed me to use that slide, so I'm going to be using this forever now. I like it. Okay, next up. So we've got these architectures, I've mentioned them. Worth mentioning effectively, if you look at the Intel AMD and Power, they're looking towards the same sort of approach, the same sort of area. Whether you're looking at cloud, you're looking for IoT, you're looking at big data, that effectively where we see a lot of the actual requirements coming from customers. If you're in Z, the Z land is still very high density workloads. And yes, there are still lots of customers who are looking at it. And IBM is actually getting more customers looking through their Rockhopper program to get more and more workloads onto Z. Which is good, because the more people are using a ubiquitous operating system, the better. Everything becomes more of a commodity, whichever operating system architecture you're actually sitting on top of. And then the new one over the side here is ARM. So if you want to do massive scale, that's exactly where we think this is going to be. But this is just a personal note. This is not Red Hat saying, it's a pity we're not going to support the Raspberry Pi. It's a pity, I know. But anyway, I'm working on that one. As soon as I get that one fixed, I'll let you know. Anyway, so that's all well and good. I've been talking as an operator. I'm managing these systems. This is all great stuff. What about the people who actually, you'd probably say, actually really warrant more help? And that is we've got to do things to make it easier for a developer to take on the latest, greatest systems. So operations are going to get the tools they need. You'll be able to take out, you'll be able to manage these systems and move on. We've got to make it easy for a developer to basically decide, I'm going to go on this platform compared to that platform. So what we're trying to do is make it as easy as possible. So we call this very simple, and if you've ever written any code in your life, you'll know that the very first thing you ever write is hello world. So we want to make it so simple that the very first thing you do, or it's easier to do hello world on RHEL than it is anywhere else. Ability to plan, ability to make it simple, and effectively you're taking on those stable tools. Whatever they're trying to be, it's out of the box, they're ready to go. You're not having to spend hours trying to find the things. It'll allow you to basically move them forward. Now this one is, well, there should be a nice little line that differentiates a little better, but this is effectively, and this is the official line here, this is the intended release strategy as we move forward. In 3 years' time, you'll see the intended launch of the next major version. But every 6 months, you'll see the updates come through. The same thing as you see at the moment, say from 6.5, 6.6, 7.5 to 7.7, etc. Those will come out every 6 months, but you'll be able to set your clock by it. They will come out, they won't wait for particular technologies or structures. They'll come out so you'll know that they'll come out, so you can put that into your own schedule in terms of how you update. And the lifecycle support will remain, that will give you the ability to stay on one particular subversion for up to 2 years, and at the end of it, you'll also have the extended life support. So we're effectively saying this is the structure we will continue to use, and you'll basically be easier if you decide when and how to do things. Now, one thing that if you just type in yum onto RHEL 8, you're thinking, why are we even worried about this? But effectively, we have a new version of the update manager. Why is that important? Well, if you've actually built and written applications that extend yum, then the most important thing is some of those extensions need to be looked at, because there is now an API that allows you to extend how the actual update manager works. The yum version 4 is designed to work in this new idea of basically having applications and base running at different timings. So it basically has a better idea, it has more structure, it has more capability to allow you to manage the systems as you move on. So, containers. We couldn't talk about anything to do with Red Hat unless we mention the word containers, and the great news is I've got it in by slide 8. Now, there is something here, and first thing is, don't worry the fact that I've got a whale on the left-hand side moving to something else. If you just type in any Docker command, it's still going to work. The difference is, this new stack on the right-hand side, which I'm going to cover, is a better approach to do the same thing. Because at the bottom here, you'll notice, and I'm going to emphasize this, we have a very important word, the very important statement here, the Open Container Initiative. It's the standard for containers that everybody has signed up to, including Docker and everybody else. The difference is we're giving you the tools to be able to do and run and manage and control those containers far more effectively from the operating system upwards, which are Podman, Builder, and Scopio. So if we look at containers in terms of what they are, the most important thing about containers is they're Linux. And the most important thing about Linux is it's Linux. Sorry, I had to get the jokes in. But what we have here is effectively what makes the container stack the most important thing that we actually provide. And of course, unless you have something else. At the bottom, it doesn't matter where you're running it, whether you're running it on a physical box, virtual machine, private cloud, public cloud, it's exactly the same. Whichever architecture we're talking about, it's exactly the same. We have namespaces, C groups, Sec Linux, and SE Linux that provides us a secure environment to make sure that whatever runs in a container doesn't break anything else. It doesn't break anybody else's container, and it's controlled within the container itself. I know we normally joke that containers don't contain, but when you look at namespaces, seccomp, and SE Linux, containers do contain. It gives you the ability to make sure that nobody's run off, no one's going to break the system, there aren't any ways around it. Application, when they do the wrong things, they don't take out something else that you want to run. It gives you uniformity, it gives you a secure environment to work from. But containers themselves, you have to look at the infrastructure to run them, to build them, and to manage them. And a container, of course, is really just the minimum set of requirements to run an application that sit on top of the rest of the stack. So no matter if you're still traditional build compared to effectively cloud native, these tools, which I'm going to go through, I will go through them honestly, are actually going to provide you those capabilities instead of just one large binary module. The important thing in the middle is, if we look at things like Quay, it is a registry for the enterprise. So a way to make sure that all the things I've already been building and I've been using, I can now find, run, and build, and then integrate and deploy within one sort of environmental controls. I'm getting more of the tools required to make the actual container infrastructure be more prevalent, more useful, something that I can basically get going today and know it's going to last for years to come. So if we look at these in a little bit of detail, Podman, very simply, as you see from this, lightweight, no daemons. Why is no daemons important if you're running containers? Well, most importantly is there's nothing to break. There is no, I don't have to run this as root. If I don't have to run it as a root, then I've automatically saved myself a hell of a lot of hassle from something that will break and someone will get the wrong privileges, etc. You're running this within user space. I've just removed half the problems you're going to get from containers straight away. I'm doing it in a very small and lightweight position, and I'm doing it through open source and open standards compliance. So I'm able to create and maintain the environment as I move on. If nothing else, that's a great start. If we look at Builder, Builder is a way that I'm going to take what I've got and basically make these containers simple. I can basically make sure I can do them again and again. I'm making them reproducible. So I have the base level, I have an OS update layer, I have the runtimes and the application layers, and the dependencies that basically come together. I'm making it simpler to build those containers that it's actually going to run my workloads. It's scriptable, but I'm also using it to minimize my images. I'm basically making sure that my containers and my images are as small as possible. The smaller those images are, the more I can run on my infrastructure, be it local or be it on the cloud. I'm doing everything I can to make sure these systems work effectively and efficiently. So then we get into the third item. Again, this is all to basically make it as simple as possible. So I have my image registry, wherever it might sit. It doesn't have to be on OpenShift, but obviously we'd say that this is a good place to run, for example, your platform as a service. But Scopio is the way that I can basically inspect those containers, I can push and I can transfer those images, and I'm basically in control of where they are. And if I want to move them from one registry to another, that's the task of the system. Between those three tools, which basically make up the container, you basically are using and managing, and you can then extend as we move on. So this is the beginning of the road to turn containers into enterprise bulletproof class components. So it's also worth mentioning, in terms of my timing, I'm probably running a little ahead, so I should try and slow down a little bit. But we've had a few little acquisitions over the last few years, and there's one worth mentioning in a little bit of detail. So CoreOS. We purchased this specifically to be the component operating system for OpenShift. So if you looked at the new OpenShift version 4, the actual operating component, which you'll self-deploy, is now CoreOS. So this is a container operating system. So why am I mentioning it today? Well, CoreOS is now using the RHEL 8 base. It actually comes together and actually becomes part of the system. So when we build RHEL 8, CoreOS is also going to be built as well. And OpenShift basically will take that, and any changes, it will basically move it forward. If you're not aware of what it actually does, effectively a container Linux is an immutable operating system. So it means you're not managing it. OpenShift, in this case, is managing it for you. An immutable operating system basically has fewer attack vectors. You can't attack it because effectively you just replace it with another one. So it makes it simpler when you're looking at these sort of massive scales to basically make the best use of all the environment you have. Anything else worth mentioning while I'm here? So the APIs remain the same, the infrastructure itself remains the same, but you now have effectively an environment that can be used. It is worth saying that basically Atomic, as we had in the sort of the previous position, is superseded now by CoreOS. Now we got an interesting one, which is the universal base image. Now, the universal base image would appear to be something have we actually had at somewhat of a surprise moment. Because UBI, I did think we'll get some in this in, is effectively a version of the base operating system, which is free to use. Free is in terms of using that to develop applications, using them, but it doesn't provide support. If you want to take the universal base image and have it supported, then effectively you put it on top of RHEL. But if you're a developer, you could develop on top of the UBI, and you can basically make the system work. It has a whole series of the RPMs that basically comes with it, and you can basically use it, and you will be guaranteed that that application, when run on top of RHEL, will basically provide you a supportable and sustainable operating system. You can run the UBI on whatever you want because effectively it's a container. But it allows developers to basically move forward in terms of something they know they're going to get. I always know that I'm going to get the same APIs, the same experience, because effectively I'm running on RHEL even when I'm not actually on the RHEL platform itself. So it's really down to, if you wish to, and as I'll show on the next slide, so applications you'll see will come up with the terms of RHEL ready when people are basically bundling these in. So what this means is, if we look from left to right, if I just run UBI on top of any platform, it will work, but we can't support it. If it runs on top of basically our standard platforms, it's supportable. And obviously we look in terms of the applications, in terms of how it sits and it works. And then we'll do our very best to make sure that application, if we've not certified it, can work, will work, etc. Over to the right-hand side here, where we basically work with partners and we've made sure those applications, those APIs, all work through, and we can give the most seamless support regime there is possible on the environment. So that is the first section.